All right, so what is the smallest positive real number? Is it 0? No. 0 is not a positive number, so it can't be the smallest positive number. In fact, you could say, using the terminology that we developed in the sheet on logic, symbols, and such, the set of positive real numbers is just the set of x such that x is a real number, so we say x is an element of the real numbers, and x is greater than 0. So since 0 is not greater than 0, therefore 0 is not an element of the positive real numbers. I keep writing out the set of positive real numbers. There is a symbol for that. It's like that. That's the positive real numbers. However, it's not quite universal, and people sort of write that differently. Some people put the plus at the top, some put the plus at the bottom, and there are other notational things. I love notation like this, but I always recall one of my professors in undergraduate study in Michigan State University. I remember him handing back to me one of my papers, and he was passing back everybody's papers, and then he looks at me and says, "Reese, would you please use more words and fewer symbols?" I was like, okay, fine, and I did. But see, I like writing stuff. It's just it's compact, it's concise, it's pretty. I like it. Anyway, there are people who find it annoying. I will try to mix it up and do a little bit of both. All right, so 0 is not it. 0 is not the smallest positive number because it's not a positive number. If you put down 0 as your answer to this, I would like you to stop the video and think some more, and then come back when you have a different answer, because it's not 0. Okay, so do that. Now, for people who didn't say 0. Now, I don't know what everybody said, because it's not really two-way communication here at this point. In the classroom, we're going to have some of that, but I don't know how much classroom time we're going to end up having. All right, so I'm going to entertain some of the popular answers I've gotten to this question over the years, because I've been asking this question to classes for 30 years. And there's like certain answers that keep coming up. So people try to come up with the idea that I want to do like 10 to the negative something, and it has to be something huge. So what if we do like 10 to the negative infinity power? So that's basically like saying I have 0.000, and but it like goes forever somehow. All right. So the problem is that this particular set of symbols doesn't really have a clear meaning. So we have a relation called exponent, and we know what 10 to the negative, 100 millionth means. All right. We know what that means because both 10 and negative 100 million are real numbers. The problem with negative infinity is it's not a real number. So the relation of exponent is not defined for a concept like infinity that's not a number. Now, you can sort of rewrite this in a calculus-y way that might make sense to you if you look at it, and maybe you've seen some of this kind of notation in pre-calc, maybe not, depending on who is teaching it and so forth. So what you might rewrite this as the limit as n approaches infinity, of 10 to the power of negative n. All right, so that means I'm going to go 10 to the negative whatever, and then I'm just going to make that number get bigger and bigger and bigger and approach infinity. These symbols all are clearly defined because n is a real number, and then I'm doing a limit. So what we're going to learn eventually in this class is that this limit is 0. So you're back to having 0, which is not a real number, so it can't be the smallest positive real number because it's not a positive number. All right, so other ideas that people come up with are sort of similar to this, and sometimes people come up with this first. What if I put 0.0 repeating and then put a 1 at the end? All right, so I'm going to put infinitely many zeros and I'm going to put a 1. So the problem is with saying I'm going to put infinitely many zeros and then put a 1. Well, as soon as you have infinitely many, you can't have and then. There's no and then after infinity, because infinity doesn't have an end. So you can't put the 1 after it. So nice idea, but no. It's basically doesn't have meaning. Another fun one that people try is so related to this, what if I try to do it like this? So what if I try to go 1 minus 0.9 repeating? right? Because then, like, these are both real numbers, so I can do minus. I don't have the problem of doing infinity and then putting a 1, so, because I can just have infinitely many 9s, and then when I subtract them off, since I have infinitely many 9s, but it's not quite 1, I'm going to have something that's not 0, all right? But here's the problem. 0.9 repeating actually is 1. Now, we're going to prove that using calculus in this class, but in the meantime, you can get a sort of a pretty good idea of why it's 1 by looking at some algebra. So we know that 0.3 repeating is equal to 1/3. Everybody knows that, right? So just multiply everything times 3. So if I multiply both sides of the equation times 3, then I go 3 times 0.3 repeating. Well, I have infinitely many 3's. I'm going to multiply them all by 3. There's no carrying or anything, so it makes sense that should be 0.9 repeating. And 1/3 times 3 is obviously 1, so 0.9 repeating is 1. All right. Now, this is sort of loose justification because, for one, it's not clear that we can really do 3 times 0.3 repeating and get 0.9 repeating. That's not clear at this point. It's not unarguable. Also, there's a little bit of like, if you really think about what 0.3 repeating being equal to 1/3 means, you've learned this, and you've learned it because of division, right? And as we do this, and we get 3's and 9's and 3's and 9's forever, okay? But what does that really mean? You're going to learn in this class what this really means. You're really looking at an infinite sum right here. That 0.3 repeating is really the sum from n equals 1 to infinity of 3 times 10 to the negative n. And likewise, this 0.9 repeating is equal to the sum from n equals 1 to infinity of 9 times 10 to the negative n. Now, if you haven't seen the summation notation, you're supposed to have done that in pre-calculus, but I'm not convinced that everybody always gets to it. But if you haven't, don't worry about it, because when we get to really doing it, we'll review that. All right, but the main idea here is 0.9 repeating is 1. We are going to prove that in this class, although we haven't yet. Therefore, 1 minus 0.9 repeating is actually 0. So that's also not the smallest number. Now, this video is running a little long, so what I've given you here is 4 possible answers to this question that are all not right because they all turn out to be 0. So what is the smallest positive number that is not 0? So you might have an idea what the answer is now. I'm going to break and come back with a second video and talk about what it really is and why.